Ladies and gentlemen, data scientists and data analysts, hello and welcome to a new episode of the Data Shaman series, in which we explore new hacks, tips, and techniques that we data scientists use in order to solve interesting problems. And so could you, whether you have coding experience or not. In particular, in this episode, we are going to try to approach one of the problems from three different perspectives. One using no coding experience at all, which is classified as easy. Another one using a high-level programming, classified as medium, which means a package. And then finally, we're going to do this from scratch, using a lot of coding. So I hope you're excited. I hope you follow up, and please let me know in the comments below if you have explored any of these methods before and whether you have any preference. Okay, without any further ado, let's get started. Just a quick announcement. If you notice some lag in the video, between the video and the audio, that's normal, and that's because I haven't yet updated my webcam. I will do that in the next episode. Okay, so let's get started. The problem that we are going to explore today is called TF.IDF, or Term Frequency Inverse Document Frequency. And that is very, very useful for many applications in data science, especially in text mining and information retrieval. So whenever you are trying to, let's say, classify documents, or trying to search for terms in documents, or search for documents using terms, or even doing recommendation of documents, this is very, very important. Like, this is, if you want, the holy grail of any text mining application. Okay, so we're gonna get started using Orange, which is a package, a software that you can install, and it has a lot of capabilities if you know how to use it, and of course if you know how to install it, because it's pretty tricky at the beginning. I used Conda to install it on Linux, and it's working magically fine. So now I did save us some time, and so that I don't have to create these documents in front of you. I did create them in advance. So we're gonna need 3 documents just to start. These are how they look like. We can put them in a folder. Al likes to code, and so should you. Al like to chill, and that's okay. So this is the first document. Second document, she likes me for me, so why not like her for her? Control save. That's the second document. And the third document, who does not like ice cream? Who does not like chocolate? So with TF.IDF, we're gonna see which are the words that stand out in these documents, which are the most representative of each of the documents, and of course keeping in mind that this is why you're gonna see like happening all the time in all 3 documents, because we want it to cancel out, even though it's frequent in these documents. But it it's not document specific, it's the whole corpus specific. Okay, represents the whole focus. So we put them in a folder, TF.IDF. You can put them in any folder. And first thing we're gonna do in Orange is import the documents. So we're gonna specify where this folder is, TF.IDF. Okay, next you're gonna plug in corpus. and corpus is going to choose where the features are in content. Okay, and if we look at it with the data table, you see that content has the text. Here we go. Now what we're gonna do, now we have it as sentences. We're gonna have to tokenize it, split it into words, into tokens, and then calculate a score called TF.IDF for each of the words that determines the importance, the weight of each term in this document. Okay? Okay, let's do that. So let's see. So I did some things in advance. I'm not gonna lie. By default, I think you have this. You don't have it as lowercase. You have this. This is what you have by default. Maybe you do have the stop words, but let's keep it this way so that we see what's happening. Okay. Then you want to get the pre-processed text into bag of words, and here you have the choice for term frequency as to whether to count how many times each term occurs in the document or whether it occurs or not. These are the most common two possibilities, and in the document frequency, the most common one is inverse document frequency. I think the smooth one is the one that's the log of 1 minus 1 over document frequency. Okay, let's see what we have here. Oh, there's a lot of stuff. So we have words, we have punctuations. I don't think we want to keep the punctuations, so first thing we want to do is here in the pre-processing, we're gonna do regex. Okay, go back here, see what this gives us. Okay, punctuation is gone. We want to do a lowercase to make sure caps and non-caps all merge into some word. And let's also, since we're at it, get rid of stop words, meaning frequent words in the document, in the English dictionary, like she and for and her. They don't mean much. So let's get rid of those in the pre-processing. Remove stop words, and let's lowercase. Okay, let's see what this gives us. Now we have a few words. Now the problem with this is, as you see, like and likes are not being considered as one word, and we could fix that using stemming. So let's go back and pre-process. Usually it's not even listed here. Well, it's not, so we have to, it's in the normalization, I think. Yeah, here we go. And by default, we are gonna use the most common stemmer called Porter stemmer. It's a kind of lemmatization, so like, likes, liked, liking, all of these words get stemmed and to be considered as one word, one root. Okay? So now if we look at this, you see like and liked have already disappeared because they merge into one word, and since they occur in all of these three documents, they are of no importance. Okay? So what's important is that in document 1, Al stands out. It stands out a lot because it appears twice. Then chill, code, okay. In the third document, chocolate and ice cream. Now, if we were to use bigrams, ice cream would become one word. Okay? But we're gonna keep it simple, and that's it for this. The easiest solution, the no-code solution using Orange. Now, are you ready for some coding? I promise this is gonna be very simple coding. Let me see, where do I have a window open? Okay, now let me zoom this a little bit so that you can see. Okay, well, forget about this. This is something we're gonna need later on. I just have been preparing some things so that you don't have to type. Please don't forget to comment which of the methods you liked most, or which one works best for you, which one have you explored and which one will you explore. So now we are going to use scikit-learn using IPython. Okay, so we are in IPython, and actually if you want we can exit, quit. To access IPython, just type IPython here. If you don't have it installed, it's pip install IPython. We could also use PyCharm, we could use Atom, we could use Jupyter. We have many options, but in order to keep it simple, I'm gonna use IPython. So we're in it right now. First thing we're gonna do is we're gonna import scikit-learn. If you don't have it installed, pip install sklearn. Okay, so let me search for the sklearn import function. Wait, okay, here we go. It just has a built-in TF.IDF vectorizer, which is pretty cool. No, you just do this, and in like 3 lines of code you're gonna see how we could vectorizer equals TF.IDF vectorizer. Now we could do we're gonna fit this vectorizer dot fit transform. I think that's it. Fit transform. The documents, which is okay. Now we just need a corpus, right? We just need to import the data and put it in this in here. Now the function, let's say soon, call it soon, because we're gonna work on it. Now see, it's just 3 lines of code, I promise. Now in order to get to read the files, it's a little bit more than 3 lines of code. It's actually more than doing the whole TF-IDF. It's funny. So list, no, that's not what I want. OS, yeah, OS, here we go. So all you need is import OS to save some time, for file name in the directory. In this case I have it in my home directory. You open each file, as it's open you read the text and you append it into a list, the list corpus that we have initialized at the beginning. Okay, enter. Let's check it out. Corpus. Now we have the 3 files already listed here. Okay, so where was this function? Instead of soon here we need corpus. Okay, bam. X has a sparse matrix with all the TF-IDF scores. That's it. 3 lines of code. Not even 2 lines of code. I mean, not counting the import. Isn't this cool? That's even easier than Orange, I think. So what we could do is, I think to array would display it. To array. I think so. Yeah. So as you see here, we have 3 documents, and here you have the, if you want, here we have the size, the dimensions. 3 documents by 24 features. 3 documents by 24 features. isn't this cool? And to get the features is x dot extract. Okay, let me look this up real quick. I think it's here. No. TF.IDF with SKLEARN. Okay, I think it's here somewhere. I've seen it once before. Okay, get feature names out. That's it. From vectorizer. Vectorizer dot get feature names. That's it. Those are the features. Isn't this cool? Of course, we could remove stop words. We could do a lot of things. Get stop words. We could do a lot of things. But this is like the default function. Okay, you have these words, and for these words, you could store it into pandas directory, but we're not gonna go that far. I like this solution. I want to keep it simple. Now, last but not least, you could pause that video if you want and have a break. We're gonna now face the bigger challenge. So in this case, we are gonna use corpus as it is. So this is done already. We don't have to do it again. Now, what we have to do is we want to go over every document, tokenize, and extract these words to calculate term frequency. That's step number 1. Then we're going to store them into something called dictionary. Okay, and this is why I'm going to start by doing some declaration. Okay, wait. So we want to declare dictionaries with default. Okay, here we go. I did this in advance to save you some time. And yeah, we're gonna need 3 dictionaries, one for the document frequency, term frequencies, and inverse document frequency. Okay, what this does, it initializes the dictionary with default values. Okay, this is done. Now we are now going to go over these documents for d in corpus. Well, actually corpus dot for d in corpus, yeah, for every document in corpus, for every token. Okay, let's just save this as tokens equal t for t in d dot split. Actually, let's do this ds equal d dot split. So now we are tokenizing based on space, which is a very simple way. We could use regex in order to do it based on white space. Let's keep it simple for now. T in ds. Okay, then let's print tokens and see what this gives. Okay, see, one of the simple things we can add is lowercase t dot lower. Okay, we could also get rid of stop words, usually from NLTK, from NL. If I have this installed, from NLTK import stop. Okay, let me just NLTK stop words. Let's see what's the exact path that we have. NLTK.corpus. Okay. Corpus import stop words. Come on, baby. Okay. Yep. So I think it's stopwords.english, right? I think it's stopwords.words English. Let's copy this since we're at it. Okay. Source not found. Oh, yes. What? Yes, let's do this. What's going on here? Okay, never mind. We are gonna skip the step because you even have a word tokenizer, so we don't have to use the split anymore. What's wrong with stop words? I think I have to reinstall the package of NLTK. I knew that something was wrong in it. Yeah, something is wrong with the package. Let's forget about stop words for now. Okay, you could also like download a CSV file with or list of stop words. Okay, so let's assume that those are the tokens. So tokens. Now what's being displayed is the tokens of the last document. Now we need to store these for T in tokens. TFS of the document. So we need to enumerate. So we need an index for every document. Enumerate TFS of E T document token. Okay, so we're creating a kind of a matrix using dictionaries. Some coffee. TFS E T equals. So if this was just binary, it would be very simple. We would just do that, and that's it. TFS. We would have for every document the words and whether they occur or not. Okay, but we are gonna do the more advanced one, which is this. And this time it's gonna work. It's gonna work. It's funny because I have pre-declared them in advance, but usually this should bug, because if I reinitialize, where is it? What have I done? If I reinitialize this or delete and then run this, oh no. Actually, TFS. I thought this was gonna complain. Al has 1. Oh, I reran this. No, it does say plus equal 1. Okay, one second. Remove TFS. What am I doing? Del. Okay, TFS does not exist anymore. So now let's do this way. TFS. Okay. Now let's run this. It should actually bug because it has not been initialized, TFS. So this should bug. Oh wow, TFS. It has not. Oh, it has, but it initialized to 0. Okay, never mind. So we still have to delete del TFS. Okay. And now what we're gonna do for T in tokens, if E in TFS and T in TFS of E, then do this. Oh, I see. What have I done? That's crazy. It was still doing equals 1. Okay. Forgive me. I was doing... Okay, I still want to show you that this would bug. So, TFS plus equals 1, even though it has been initial. See? Okay. So what we have to do here is... we have to make sure that this has been initialized. Else initialize it. TFS of E of T equals to 1 and 1 da 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 da. Oh yes, definitely you're right. I deserve you to bitch. TFS. Here we go. See, now we have 2's for where these words occur twice. Sorry. Who does not like chocolate? Who does not like ice cream? Who does not? Ice cream and chocolate are unique. Okay, now what we usually do, we normalize. So we want to make sure that based on the document length, these terms are weighted. When the documents are almost of the same size, we don't have to necessarily normalize, but if we have small documents and large documents, it's very important to normalize. And to normalize, we would have to, I think we could do it here. So basically it's TFS divided by the length of DS, right? Let's see if we could do this like this. Length of DS. So based on how many tokens each length of DS. And the reason why I could do this way is because no, I can't do this way. So I was thinking of rather than doing another for loop, just doing it this way. So so if you have 2 divided by let's say 5, is it the same as 1 divided by 5 plus 1 divided by 5? That's the question. It's not. Yeah. Oh shoot. So I think we have to do another loop for that. Oops. Yeah, let's do it here. For T in tokens, then TFS is equal to I think, do we have to exit the whole thing? Yes, because No, that's fine. That's fine. We don't have to. Equals. So now we are gonna update these divided by len of ds, right? Number of tokens normalized by number of tokens in each document. Yep, let's try that. Except that every time we have to, so we have to be careful, because every time we're running this, TFS is being uninitialized. Yeah, you see what I mean? Yeah, we just want to make sure that so you have to be extra careful whenever you use IPython. Here we go. This and then this. And now TFS, and now we can check if this works. Okay. So I know that all occurs twice in this document that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. 2 divided by 12 equals 0.16. Interesting. Interesting. I made a mistake. Where is that mistake? Oh man, we have to I don't want this episode to go forever. Oh shoot. Can I copy it this way? Yeah. Oh. Can I paste it now? Now this way? Because we don't want to keep. Oh shit. This is horrible for you and for me and everyone watching this. I'm sorry. Should have done this in advance. Okay, let's double check. Yeah, that's wrong. Let me see why. 14 tokens. 14 tokens. So now this is going over this. Oh, yes. So we're going every word, and then for every word it's gonna be divided by length of its document, length of ds. Let's try something, a little debug here, et and len of ds. See what's happening. Okay. Okay, everything looks fine except that. What? It's 15? Why? I thought this was 12 and this was 15. Okay, corpus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Why did I divide by 12? So 2 divided by 15. 2 divided by 15 is 0.13. Is that what TFS has for L? No. It's what it has for her. I think these DS are messed up. Yeah, I think these DS's are messed up. Okay, wonderful. Enumerate the so for this DS tokens 14 DS 13 tokens. Okay. Why? See why we use already made stuff and we don't reinvent the wheel? But this is very important for those of you maybe who want to learn about how these things work. So divided by len of ds. Could it be that this needs to be converted to float? No, I don't think so. TFS equals, or maybe because this is accessing itself again. No, of course not. The float would have to be here. Float, if at all. But I don't think this is the issue here. The issue is TFS all is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. That's weird. 12? Oh yeah, if it's 12, that's fine. 2 divided by 12 is... No, that's not okay. It's the double. 1 divided by 12, 8. What happened? Okay, to be safe, we are gonna do this. Play this. We're gonna play this safe, and this is what we'll do. TFS2, because I think we are messing up with TFS equals TFS2. Okay, and just keep it simple here. Len of ds, print ed. Okay, ds TFS2. What do we have here? Al has 13. Okay, I think now the doubles make sense, so this was messing up with. Okay, 13. So what is this? Is it 2 divided by 12 or by 15? Yeah, by 15, and that's because it's counting 15 terms in this document, 12 in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, okay. One is unique. Yes. One has the unique terms and one has the non-unique terms. This is the difference. Okay. So, I think this makes sense now. Even though it's 15 here, but if you count the doubles, then it gets reduced to 12. So that is okay. That is okay. Okay? Instead of having L twice here, it's appearing once. Okay, so the term frequencies are done. Now we have to calculate the inverse document frequency. And to do so, we are going over every document for D in corpus. Okay guys, we have to make this short and we have to stop here. I think if you want more, let me know. This is way over the limit. And please comment below what you think of these three solutions. Which one have you tried, and which one would you want to explore further? Thank you, and have a wonderful data time.